All right. Good afternoon. All right, I'm going to do a video on a couple of the topics that we just finished, but there's a couple things I did not get in the notes from last time, so I said I would do a video on them. So our first one is following triangle right, acute, or obtuse? Well, I'm still going to test it using Pythagorean. Okay, so I'm going to look at it and say, well, my longest side is 10. So we're going to assume that's our hypotenuse. So that's the one that goes by itself. And then my other two are my legs. So I'm going to do 5 squared plus 7 squared. And I want to know, does that equal 10 squared? Well, this side is 100. This is 25 plus 49. If I add those together, I get 74. Okay, it is certainly not equal to 100. But if you remember, when our hypotenuse is bigger than our legs. Remember, I drew a little guy like this. His legs aren't long enough, so he's kind of therefore obtuse. Okay, if the legs had been longer than the hypotenuse, then it would have been acute. But in this case, he is obtuse. Okay, all right. So a couple others in the packet I did not get through that I wanted to would be number 19. Okay. Number 19 said find the value of x and the measure of ABC. And if we remember, the exterior angle is equal to the sum of these two. Okay. So I'm going to do 5x minus 13 is equal to the sum of these two. And if I add them together, I get 2x plus 68. That's what I have to solve to find x. Okay. All right. So I'm going to subtract 2x. And I get 3x minus 13 is equal to 68. Okay. And now I'm going to add 13 to both sides, which is really balancing the equation. So I get 3x is equal to 81. If I add those two together, if I divide by 3, x is equal to 27. Okay. So we found our x value. I want to remind you on a multiple choice test, you got a couple things going on here. Is one, if they say find the value of x, you're done. But if it would have just said find the measure of angle ABC, now you got to plug it back in. But ABC is this one. So I have a couple ways of approaching it. Well, I can find this one and then realize that 3 of these will add up to 180. Or I have a linear pair going on here, so I can plug in the 27 here. Okay, I'm going to choose to plug it in the outside one. And if I do 27 times 5 minus 13, I'm going to get 122. Okay, so this angle is 122. So since these are a linear pair, if I do 180 minus 122, I believe that this is 58. And that would be our answer for ABC. Now, I do want to point out that on a multiple choice test, there'd be a bunch of answers. One of them would be 27. One of them would be 122 or 58, and one of them would be 122. But in this case, if it said value of x, this is the one you pick. If it says find the measure of ABC, which is what we should be circling in terms of what the question is, because that's good for standardized tests also, it would be 58, because you computed this to be 122, and then they're supplementary, so you subtract from 180 and you get 122, or you get 58. So our correct answer here is 58. Okay? All right, so now I'm going to flip over, and I'm going to do number 22. It says determine the measure of x and then the measure of the angles in the triangle. Okay, well, if you look at this, it may not look like it, but I have two sides of the same, and if two sides are the same, it's isosceles, which also means that the base angles are the same. So these two are the same. So that means I can also replace this one. I can copy this here, and I get 2x plus 11. Okay? Now I got to think, well, how am I going to solve for x then? Well, I have what all the values are for inside my triangle. Yes, the lengths have no bearing upon anything. So if I add all these up, I have 2x, and x is 5x. I have 11, and 11 is 22, minus 2 is 20, is equal to 180. So that's really what I'm solving to find the measure of x. So I'm going to go and subtract 20 and I get 5x is 160. And if I divide by 5, I believe that x is then 32. Okay? All right, still need to find the measure of all the angles. Well, if I plug it in here, if I double 32, I get 64. And then 64 and 11 makes it 75. And if this one's 75, this one must also be 75. And if I plug it in here, I get 32 minus 2 is 30. Well, if I add these up, I get 150, and 30 gives me, in fact, 180. So that's a way to go back and double check it. Okay? All right, so I'm going to look at 23 and 24. We have right triangles there, and if we're asked to find the missing sides, remember how we're going to go about doing that is using Pythagorean. And of these three, which one is our hypotenuse? Well, it's opposite the right angle, so it's 45. So that's what I'm going to leave by itself. So I get 45 squared is equal to 18 squared plus e squared. 18 squared, I believe, is 324. So I had to verify that. Okay, I do not know what 45 squared is off the top of my head. Is 2025. Okay, so I need to isolate this squared term. So I'm going to subtract the 324. Okay, so I subtract 324 and I get 1701. So I get e squared is 1701. And then how do I undo that squared? So I'm going to take the square root of both sides. So if I take the square root of my answer, I'm going to go up and grab it. E is equal to 41.2 if we round it to one decimal, because it's going to keep it, the 4 is not going to round us up. Okay? All right. So we're going to do 24, and I think there may be one more, or that's it. No, I think that one's it. So if I look at this one, which one is my hypotenuse? Well, again, it's opposite the right angle, so it's 17. So I'm going to say 17 squared is equal to f squared plus 15 squared. 17 squared is going to be 289. 15 squared I know is 225. Okay? So now I'm going to simplify this by subtracting 225 because I got to isolate the squared term. So I get f squared is equal to 289 minus 225 is going to be 64. But it's not my right answer. I have to take the square root again. When I get rid of the squares, I'm going to take the square root. So f is equal to 8. So the length that makes this a right triangle is 8. And the length that made this one a right triangle, the approximation for it was 41.2. Okay? Are there any others in here? I don't think so. I think we did almost all the other ones. Oh, the other one I did want to hit again, because we struggled a little bit with it, was number 13 in the packet. And this is find the measure of FLM. So it is not just find the value of x, and I got to caution you on that, because standardized testing, you may think, oh, I'm done when I solve for x, but I'm not. Okay, so the question is, are these two equal? Well, they're a same side interior, so they're not. But another way of thinking of it is I could copy this one up here. Okay, and then I realize that those are a linear pair. Okay? All right, so I'm going to add those. So therefore, if it's a linear pair, they sum to 180. So if I add those two together, I get 5x. If I add negative 8 and negative 12, I get negative 20. And they're going to sum to 180. Okay? So I'm going to add 20 to both sides to undo that, to get rid of the negative 20. So I get 5x is equal to 200. Okay, if I divide by 5, I believe I get x is 40. So my x value is 40, but I'm not done, because we need to find the measure of FLM, which is this one. Okay, so I'm going to plug it into the 3x minus 12. So 3 times 40 minus 12 is 120 minus 12, and that would give me 108. So I get 108. Okay, if I would have plugged it into here and worked it out, I believe I would have gotten 72. So I can guarantee on a multiple choice, you'd see three of your answers would be 40. You'd see 72. You'd see 108, and you probably see a couple others that are made up, but in this case, if it just asks for X, you pick the 40, but on this one, you put on FLN, you have to pick the right one, which is going to be 108. Okay? All right. Hope this helps, and good luck on Thursday or Friday, depending on which block you have it. Thank you.